In this video, we're going to continue studying intervals, and I'm going to give you 3 additional concepts about them: interval inversion, compound intervals, and how to count the different intervals contained in the major scale. So, first of all, interval inversion. We've already touched on this in kind of a quick and dirty and hopefully maybe confusing, hopefully not too confusing way when we were talking about key signatures. Now, the idea behind interval inversion is that because specific pitches are related to other pitches through octave equivalence, if we've got a G and a C there in a perfect fourth, there's always going to be a special relationship between this interval and the interval if we just pop that G up an octave and put it there. You see, we're still dealing with the same pitch classes, but here we have a perfect fourth, whereas above it we have a perfect fifth. But those are both intervals between some G and some C. So there's a very special relationship there. And you can hear also, I think, a sense of relatedness between those intervals. And I can really do it with any interval. If I've got some E and some C, the C might be above the E. Oops. Or the E might be above the C. You hear how close those sounds are? The reason for that relationship is in both cases, you're talking about the sounding together of an E and a C. An E and a C. So interval inversion, when we talk about inverting an interval, what we're doing, write up any old interval, what we're doing with interval inversion is we're taking the lower note in the interval and we're popping it up an octave so that now a member of that pitch class is the upper note in the interval instead of the lower one. Okay? That's all there is to interval inversion. Now, the easiest way of thinking about interval inversion is by analogy with giving change for $1. You know, if you pay for something and it costs 32 cents, you're going to get 68 cents back in change, right? This is obvious. You just know how this works. Being, at that level, and you've got computers to do that now, but back in the day, when there weren't all these things, if you were just working at a store and there's no machines and somebody buys a 45-cent piece of candy, you're going to give them 55 cents back. You just know that. You perceive these things. Interval inversion works exactly the same way, except instead of a basic reference of $1, the basic reference point is the octave. So you can think about it in terms of, oh, we take we've got this interval and we pop the other one up. We pop the lower note up by an octave. But you can also think of it this way. You can think of this octave as being the main thing that you're paying attention to. You're paying attention to that octave. And what are you doing? You're splitting that octave up in 2 different ways. Or you're splitting it into 2 pieces, rather. So if I take a perfect fourth away from my octave, what have I got left? I've got a perfect fifth. Okay? And if you look back at that chart from the earlier lesson, you'll see that works out. A perfect fourth has 5 semitones. A perfect fifth has 7 semitones. Add that together, you get 12. That's the octave. Similarly, you started out with a minor sixth with 8 semitones, inverts to a major third with 4. We're always summing to 12. Here we've done a fourth-fifth split again. So there's a very simple relationship. It doesn't matter what the notes are, so long as you know what the interval it is, the inversion of that interval is always going to be the same thing because you're just talking about splitting up an octave. And at this point, let's go to the handout on interval inversion. So here we've got this handout that's on my website. Go ahead and download this or open it up if you haven't already. This table simply lists inversional relationships. So here's the name of the interval and the number of half steps it contains, and here's the interval that it inverts to. And of course, I only need to go as far as the augmented fourth. This, again, is using only the intervals that are actually found in the major scale, because the augmented fourth inverts to diminished fifth. If I want a diminished fifth, I just read this column, it inverts to an augmented fourth. If I want to know what a major sixth inverts to, I start on this side, and I go there. And of course, the number of semitones in parentheses, those always sum to 12. So this chart is something that you should memorize. And as it happens, it is very easy to memorize this chart, because if you simply look a little bit further down on this page, you'll see some general principles about this. And maybe we can see this amount right now. Sevenths and seconds invert to one another. Thirds and sixths invert to one another. Fourths and fifths invert to one another. Furthermore, you will see that major inverts to minor and vice versa. Perfect inverts to perfect. Augmented inverts to diminished. And these are general principles. It's not just for these intervals. So also doubly augmented inverts to doubly diminished. And what this chart allows you to do is deal with the inversion of any interval. So say you've got kind of a crazy interval like an augmented third. Well, a third inverts to a sixth, so you're talking about some kind of a sixth. An augmented interval inverts to a diminished interval, so you're talking about some kind of a diminished interval. Put those two things together. Augmented third inverts to diminished sixth. So if you simply remember these things, you can quickly find the inversion of any interval. Now, I have a quick exercise that I like to do, and this will bring us back to the blackboard. So here's how the exercise works. This is an exercise that helps you to hear inversional relationships. So we're going to start with the smallest interval, so major second, minor second, there we go. Minor second, major seventh, minor second. So do that kind of feeling a beat on each one. So minor second, major seventh, minor second. Now what I want you to do is feel fewer beats so that you can hear that octave. This foregrounds the component intervals. Now I want you to hear that octave. So major second, sorry, I keep doing this. Minor second, major seventh, minor second, major seventh, minor seventh, minor second. So I want you to hear that octave, and then you make it bigger. So major second, minor seventh, major second, minor seventh, major second. And you do that, getting bigger and bigger until, of course, you're up to the major second, and then it's inversion. That'll help you to actually hear these relationships. There is one other thing I wanted to say about inverted intervals, and that is that some of your worksheets may ask you what, sorry, we can't get to that yet. Bracket that. We'll come back to that in a sec.